Welcome to the Tuolumne River Watershed, famous for its scenic meadows, rich biodiversity, and exhilarating whitewater rapids. It is truly one of California's gems. But what makes all of these magnificent features possible? The simplest answer is rocks. After all, the Sierra Nevadas themselves were formed by the massive uplift of rocks, which in turn trapped passing moisture, increasing rainfall, and formed the Tuolumne River. Throughout the system, rocks shape the landscape and form features that serve as a central habitat for plants and animals. So how did these all-important rocks get here? The majority of them were formed deep underground about 100 million years ago, as the Pacific and North American plates converged upon each other. As the Pacific plate was forced beneath the North American plate, it began to melt, sending hot balls of magma upwards until they cooled and solidified beneath the surface, eventually rising above ground as massive domes of granite some 80 million years ago. Many older rock types found in the foothills were also formed during this plate convergence. Originating as ocean sediments on the Pacific plate, these rocks were squeezed, reformed, and then scraped off onto the land during the collision. So what happened to these rocks after they formed? The combination of rain, wind, biological factors, and glaciers broke apart large rocks into smaller ones, causing them to move downhill and into streams. Glaciers played a large role in moving huge amounts of sediment downward, depositing this material largely in the Tuolumne meadows and carving out valleys such as Hetch-Hetchy until the end of the last ice age, some 12,000 years ago. Most sediment entering the Tuolumne River is produced in the upper part of the watershed, where erosional forces are greatest. They are then transported through the middle region to the lower central valley and deposited on vast floodplains, forming some of the world's most fertile soils. How do rocks control the Tuolumne River, and why does this matter? River formation is influenced by rocks at every scale, from basin-wide effects such as topography and sediment supply down to the influences of individual grains. This formation is the product of the surrounding channel geometry, supply of sediment, and the size and frequency of flows, or the flow regime. In the headwaters, the Tuolumne meanders across flat, open meadows fed by snowmelt. High sediment supply along with low flow velocities means that there is more available sediment than can be moved by the river, so it deposits out and gets left behind, as seen by the abundance of gravel bars and evidence of many previous channels, which were likely formed and then abandoned as the channel filled with material and shifted course. Moving downstream, the river enters the Grand Canyon of the Tuolumne, where it dramatically steepens and becomes confined by high granite valley walls. There is relatively low sediment supply here as the river gradually downcuts along faults in the solid rock in a series of cascades and waterfalls. Historically, it then entered the gently sloped and glacially scoured Hetch-Hetchy Valley, where it again became free to move from side to side, forming meander bends, gravel bars, and large floodplains. Upon exiting the valley into the watershed's steeper middle region, the river encounters steep, narrow confining walls made of granite and metamorphic rocks. These walls control the river's form by constricting flow in certain areas, resulting in faster water, which scours the channel bed, leaving behind deep pools. In wider sections downstream, where the water flows slower, the scoured material then deposits out, forming shallow regions known as riffles. Many gravel bars also form, often due to the river going around a meander bend, where lower velocities occur at the inside of the bend, causing material to deposit out. The diversity of pools, riffles, meander bends, gravel bars, and floodplains form the essential habitat for various aquatic and riparian plants and animals, upon which the entire food web is dependent. How do we affect the rocks of the Tuolumne? After a century and a half of mining, deforestation, irrigation, diversions, dam building, and other land uses, nearly every region of the Tuolumne watershed has been drastically impacted by human activities. The construction of large dams has decreased sediment supply downstream and altered the natural flow patterns needed to maintain the river's form, thus decreasing the availability of habitat for native species. What can we do about it? While it may be a while before impacts such as dams are removed, working to restore the natural flow patterns is an important step in protecting the Tuolumne, as it provides essential transport of rocks and sediment needed to maintain the system. This may be done by managing reservoir releases in a way that mimics these natural flows and minimizes the harmful effects of river regulation.